so this is section 3.2. This is a translation. Translation is basically taking an object and moving it up, down, left, and right, or some combination thereof. Okay, so here is our full definition of a translation and some of its properties. Okay, so a transformation in a plane that maps all points of a free image the same distance and in the same direction. So the translation of triangle ABC by X units along the X-axis and Y units along the Y-axis can be written in this fashion. Notice the way the symbol is written. It's a little pointy parentheses. So that means the translation, X and Y. So what are some properties that we have? All of these lines that you connect the free image to the image, all of those line segments are all parallel and they are all equal length. That's what that means. These triangles are in the same orientation, and a translation is also called a rigid motion. So translation is pretty straightforward. Let's go ahead and take a look at an example how I can use a translation or find a translated shape. So here's an example. We're going to translate this triangle 6, -7. So how do I do that? Well, very simply put, it's kind of like a rise over run. So that you're going to go 6 in the X direction and -7 in the Y direction, and you follow every point doing that. So if I take the A right here, what I want to do is I'm starting at -2. Okay, and I'm going to add 6 on the X direction. So 1, 2, 3, 4, 5, 6, and then I'm going to go down 7. So if I'm out here at 1, if I go down 7, 1, 2, 3, 4, 5, 6, 7, I will end up right there. So that point is A prime. So where was that point? Do you remember? Take point A, and what you're going to do with this is you're now going to change it to A prime by taking -2 and adding 6, and then taking 1 and subtracting 7. This gives me the new point for A prime, which is 4, -6. This is at 4, -6. If you remember, that's how we counted it over. I can do the same thing for all the points. So I can do it this way. I can start with 1, 4, and then B prime becomes 1 plus the 6 and 4 minus the 7, which gives me a new B prime of 7, -3. And we can do the C the same way, which started at 3, -2, and then gets translated as 3 plus 6 and -2 minus 7. And so C prime becomes 9, -9. And then you can just graph those points. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. Oh, sorry. And then 1, 2, 3 down. So that would be B prime, 7, -3, and then 9, 9, -9, which is right about there. C prime is at 9, -9, and then I can use my straight edge and draw this triangle. And that's how a translation kind of works. Okay. It's basically, if you just connect these dots, you'll see that they're all going to be parallel. You don't have to connect them. I'm just showing you that if I did connect them, all of these segments would be parallel to each other. Okay. As part of the property, they're all congruent in length. But also, if you look at it this way, if I just did rise over run, I can get to those other points fairly easy. So this over here is a 6, and this is a -7. Over 6, down 7. That's kind of like how translations work. Okay, pretty straightforward. Got me move it here so you guys can make it easy. Copy that. All right, so I have another one right here. Go ahead and do this one. What rule, translation rule, maps this onto its image over here? So how would I do something like this? How do I find the rule? To know the rule, I have to know how far it moves in the x and how far it moves in the y and in which way. So you start off by graphing each of these points. Okay, find -3 and 1. So that's P, -3, 1. And then graph 2, 3. So that right there is P prime. That's the image point. So the question is how does it move? How do I get from here to here, going in the x direction and the y direction? You just gotta do this. What is going on here? In the y direction, I'm going from 1 to 3, so that's an increase of 2. And from here to here, I'm going 3 and then 2 more, so that's a number 5. So I'm going 5 in the x direction and 2 in the y direction. So that basically tells me how this works. So mathematically, for the x direction, take the 2 minus the -3, so 2 minus a -3. This is how you find distance between points. Okay, and in the y direction, take the ending value, which is 3, subtract the starting value, which is 1, and you get 2. That's how I got the 2 and the 5. Once I have those numbers, then my translation of 5 units in the x direction and 2 units in the y direction of point P, which is at -3, 1, is the image point at 2, 3. So that is one way to write it. Or from point concept, so how do I move each point? A point x, y moves in which way? Take the x and add 5. Take the y and add 2. So any xy point gets moved in this fashion. So this is an alternative method. They will show both of these in standardized tests. You need to be familiar with both of them, please. So that's how I can find the translation rule. Just need to follow a point and you can get it for the whole entire shape. All right, so let's look at something else now. Composition. Now you're going to have composition of rigid motions, of rules. The transformation with 2 or more rigid motions in which the second rigid motion is performed on the image of the first rigid motion. So in this example right here, this is a composition of a reflection and a translation. The way it is written means you need to perform it in this fashion. First off, the little tiny circle. It has to be a circle, not a dot. The circle right here, don't make it very big. It's a small circle. That means composition. So when you see that symbol, that means to do a composition. But the order in which you perform this is, I got to do the translation first. When I have done the translation, then I will reflect it across the line L. So the translation followed by the reflection. That's what they're talking about. Okay? So here's an example. So I'm going to translate it this way first, and then I'm going to translate it that way. So because they're both translations, I can actually do one translation to represent the final piece, and that's what they kind of wanted us to do here. So let's look at this example. So my translations, okay, I'm going to do this one first. So what is that doing? What is the translation 1, -1 doing to a point? It is taking the x value and adding 1, and then taking the y value and subtracting 1. That's what it's doing. And by composition, then once I have that, then I can do this translation. So what is a translation of 3, -2 doing to this point? So this is where we're at now. So we're going to do this translation on that resolve. What does that do? It takes this quantity, so x plus 1, and adds 3 to it. And then it takes that quantity and subtracts 2 from it. So what do we get from this? So we get x plus 4. We get y minus 3. And so the translations takes any point. Actually, so because I'm doing this, I can see then what the two numbers are that I'm changing. And so I can write the final translation, the composition of both of them, as 4, -3 of a point. So that's how I can get that. Or I can do it as a point translation. So xy changes to x plus 4, y minus 3. And so these translations right here is equivalent to that composition. It results in the same answer. Okay? Now, it's a little bit harder to change a composition between a translation and a reflection. You'll just have to do on graph paper to make it easier. All right, so this is a translation, is a composition of two reflections. So what they're showing you here is that any translation can be equivalent to a double reflection, a composition of reflections across two parallel lines. Okay? So if I take this right here and I reflect it across this line, and then take this and reflect it across this line, then the orientation is exactly the same here and here, and it's just the same as a translation as I just slid it across. Okay? That's what they're talking about. And that distance right there is D, so the distance between the parallel lines, but the distance from V to V double prime, so this distance is twice that. So that'll help you figure out what your translation is going to be. So you'll know these two lines, and so you'll know the distance between them, and so then you'll know how far to add this, what to add to this to get to that. And I think I have an example here. Yes, I do. All right, so let's look at this example and see how this works. All right, so here's a composition of reflections, and I want you to write one translation for it. Okay, there's two lines, M and N. M is at 1, and N is at -1. So let's put those in our picture right off the bat. So we're drawing a vertical line. And then another vertical line. So this line and the other one are parallel. This line right here, M is at here, so this is M. This is x equals 1. This is N. And this is x equals -1. So according to this rule, I can take any point. Okay? So let's follow this and see what's going on. So let's take a point, right? And just any point we want anywhere, and let's kind of see what happens. So I'm going to start by taking some point over here. If I did a grid point, you can see it, it'll work out for you also. Let's just put a point right here. So here's a point, x, y. Okay? So according to this reflection composition, I have to perform that reflection first across the end. Okay? So that means it's going to go right here, the same distance, and then it's going to go across that. So what is that distance? And then straight across, it's going to come across here and put a dot right there. So that is the first image. That's P prime. Okay? And then I find that distance and reflect it across this line, which puts it right there. And that's P double prime. So the question then becomes is, what is that distance right there? Okay? How do I find that? Well, we know what that distance is, because this distance from here to here is a 2. That's how far apart those two parallel lines are. So that means the distance from here to here is twice that, or a distance of 4. Okay? And it doesn't matter which way I do this. If I start the point on this side, if I start a point over here, okay, it doesn't matter. So if this was point Q, and I reflect it on the line N first, that Q is going to go, let me show you so it's not guesswork. So there, it's going to go to there. So this point right here is Q prime. Now, take this distance to line M, and then space it over here. And so that then becomes the point Q double prime. And that distance is the same. See? It is also a distance of 4. So this distance is 4, twice the distance in between. This distance is 4, twice the distance between the parallel lines. So this reflection then can be written as, so the only thing that happens is I take this point and add 4 in the x direction. So the translation can be written as 4, 0, 4 in the x direction, 0 in the y, of a point. Or I can write it, take the point x, y, x plus 4, and y. So that's what's happening here and what they were talking about in that one. Let me show you a little bit nicer picture here. Okay, and so you may be asked to do some of these things, do compositions to a different one. But as questions pop up, we'll take care of them in class.